In this video, we're going to look at how to find a missing part of two intersecting chords. So you may remember that the formula that represents the relationship between these two chords is C times D is equal to A times B. And this goes back to the similar triangles that are created when these two chords intersect. Okay, but that's not what this video is about. This video is about how to find an unknown piece. So we can utilize this equation to find a missing part. Let's look at an example. So let's say that we have a circle and it's got two intersecting chords and we are trying to find the value of x. Again, we can utilize this equation up here, noticing that it's the two pieces of the same chord that are multiplied together and set equal to the product of the other two pieces from the other chord. So in this problem, that would be 4 times 10 is equal to 8 times x. That gives me 40 is equal to 8x. And dividing both sides by 8 to simplify, I get x is equal to 5. Easy peasy, right? Let's look at another example. This example is really similar to the last one, the difference being that the expression we're solving for is just slightly more complicated. Rather than just having an x, we have 3x plus 1, but the same formula still applies. We can take the two pieces of the same chord and multiply them together. So I'll have 12 times 3x plus 1, which I'm careful to put in parentheses, is equal to 8 times 24. Next, I'll distribute the 12 to both terms there, or use a generic rectangle to get me 36x plus 12 is equal to 8 times 24, which would be 160, 192. Then from here, I'll subtract 12 from both sides, getting me 36x is equal to 180. And finally, I'll divide both sides by 36 to get x is equal to 5. Now, beware on problems like this. If you were just being asked to solve, you might be done. Solve for x, you would be done. But if it were asking for the length of the chord, we'd have to plug 5 back in, which would give us 15 plus 1, which is 16.